everyone, it's Justin again. You've already learned how to graph inequalities and why they're useful. In this video, we're going to be going backwards, looking at a graph to figure out the inequality that goes with it. Here's a graph, but what's the inequality that it represents? The process here is essentially the same as graphing. Write the line as if it were a regular equation, look at whether the line is solid or dashed, then look at where the shading is. Let's do this example here. First, if it was just a line, what would the equation be? The y-intercept, or the number where the line crosses the y-axis, is -2, and the slope rises 5 and runs 1, for a slope of 5. Now we've got an equation for the line, but we've already seen several times that inequalities always have extra steps. When writing an inequality from its graph, those extra steps are all about figuring out which inequality symbol to use. First, is it an or equal to inequality, or just a strict inequality? That can be answered easily by looking at the line. Since it's dashed, we know that it's a strict inequality with no or equal to. So then the final thing we need to know is, should it be less than or greater than? There's a really simple trick to this. As long as the inequality is in slope-intercept or point-slope form, if the shading is below the line, the side with y is less. And if the shading is above the line, then the side with y is greater. On this graph, the shading is all above the line, so the side with y is the greater side. To check if you've got the right sign, test a point in the shaded area, like 0, 0 on this graph. We get that 0 is greater than -2, which is a true statement, so we know we put the symbol in the right direction. Here's our next example. First, let's write the equation of the line. This time, let's do it in point-slope form, just because we feel like it. We'll use this point here, and the slope is -1/2. Now that we know the equation of the line, we need to figure out which inequality symbol to use. There are 4 options. We know that it's a strict inequality if the line is dashed, and an or equal to inequality if the line is solid. This line is solid, and we can tell whether the side with y is less or greater by looking at whether the shading is above or below the line. This graph has the shading below the line. And now we've narrowed it down to 1 inequality symbol, so we can just insert that, and we're finished. This is the inequality. Y minus 4 is less than or equal to -1/2 of the sum of x and 2. I want to warn you about one thing. Do not try to write an inequality in standard form straight from a graph. Here's why. Writing standard form from a graphed line is difficult anyway, but let's say you manage to get 2x minus y is equal to -2 for this graph. And now it's time to figure out the inequality symbol. It will obviously be a strict inequality because of the dashed line, but which direction should it go? You might be tempted to use greater than since it's shaded above the line, but you'd be wrong. See, that above or below trick only works when the x and y are on different sides. With standard form, it's a little more complicated. This graph is shaded below and does use the less than sign. This graph is shaded below but uses the greater than symbol, and this graph is shaded above with a greater than symbol. So if you need to write an inequality in standard form, here's what you should do to make sure you get the symbol correct. First, write the line in point-slope or slope-intercept form. Insert the correct symbol, which in this case is the greater than symbol since it's shaded above the dashed line. Then manipulate the terms to get it in standard form. We subtract 2x to get it to the left side, then divide everything by -1 so the x term will be positive. But don't forget, anytime you multiply or divide an inequality by a negative value, the sign flips around. So the greater than turns into a less than. Now we've got the correct equation of this inequality in standard form. While we're on the subject of forms, inequalities can be written in just as many different ways as equations. We could write this inequality in point-slope form using several different points. Or we could write it in slope-intercept form, or we could manipulate one of those previous forms to write it in standard form. All of these inequalities describe the exact same relationship with the same graph and the same solutions. When writing an inequality to go with a graph, remember, equation, type of line, above or below. And when in doubt, regraph the inequality you just wrote to see if it matches the graph you were given. In the next lesson, we're going to apply what we know about inequalities to word problems. See you then.